Hey, Liam, I wanted to go through your lab. I think I've made some comments. This is Rev 2. I just want to do some verbal to go with it. Um, what we've done is you've told me that you could explore mass, right? Explore mass or explore spring type. So when you're exploring mass, right? When you're exploring mass, you keep spring constant, the spring constant, and the displacement constant, which you did. Uh, and then when you explore spring type, you keep the mass constant, and then you vary the spring type. And there was one more if you watch the video, and that was displacement. Oops, I'll just put a note there. Explore impacts, maybe displacement. Okay. So there's three different things to explore in this. Okay. First, well, I think you did for your mass, right? You did spring amplitude 3, varied masses, and you found your periods with that spring and that amplitude. And you plotted that nice 0, 0 there, and you've got that square root. And I believe what you did is squared these values. So make sure that you've got that t is period, right? Make sure that you've indicated that those y values have been squared, okay? And then that will be more clear. Now, it does look linear from there, right? So you've got this linearized relationship. You should find that, oops, I always get mixed up that. You should find that slope, right? And then you can get an equation. You have a period squared, right, equals the slope times your mass. And I realize two m's make it a little different or weird. Usually that m is in a k value when we work with proportionality. But find the slope, right? You can get that equation, all right? That's the purpose of linearization. You've got a relationship from where you can start making predictions. What if I did a mass of 100? Could I predict that period? Yes. If I have a period of, let's say, 2 seconds, what mass would that correspond to? So you're finding a relationship equation that connects the two of them together. So a lot of points back for this, just a little more clarification. From that point on, right, I was trying to follow your work. Each one of the graphs past the still mass versus period, right? But what have you done? You've reached to spring A, and you've explored all the masses. I don't want you to explore the masses anymore. I want you to set the mass. I want you to set the mass, say mass equals like 500, right? And I want you to explore, instead of hanging masses, I want you to explore k values, right? And you believe you do have those k values. Oops. Right? Those k values are listed right up in that table. So you can test these k values. It looks like we've got 1, 2, 3, 4, 5 of them, or maybe 6. You'll need to explore 5 to find a pattern. And from there, explore that, graph it, linearize, and you can find that. And the other thing is, I think you did and tried to compare, and you can did spring A amplitude 3, and then you did spring amplitude 1, but then again, you did mass versus period. I want displacement versus period, okay? And you need to explore that. But if you look at the data, right, if you look at it and kept your mass the same, right, it would be interesting to look at the period between the two different amplitudes, right? You've got 300, 400, 500. So you got the same masses. It's a lot of data. That's why you want to stay with the same data or the same constants. So you want to isolate displacement by having the same spring and the same mass. So you just got more data than you need, and you can't really evaluate it. Okay. So that's just some verbal reminders, and I'm just trying to get you one, kind of the purpose of the whole class in general is to get you understanding